All right, dear geometry students, welcome to lesson 6.05, dilating a line. Give the do not a try, find the slope, and put in points intercept form, and I will not be going over this. All right, today, I can use properties of slope and y-intercept to find the equation of a line transformed by a dilation. Our competency skill is model. Now, what does it mean to dilate a line? So let's say we have the line y equals x. And dilation graphically happens around the center. So here the center is the origin. And we're going to dilate by a scale factor of 2. So what does that mean? Write this down in blue in your notes. Every point in the line will get twice as far away from the center of dilation. And what does that mean? This point is, the slope is rise of 5 over 5, and we're going to double that. So double 5 is 10 by 10. And so here is the new point where when it's dilated. So the dilated point is twice as far away from the origin as the blue point. Let's look at another example from a random point on a line. So let's say you have y equals 2/3 x plus 1. If we dilate from this point, not the origin, with the scale factor of 2 is twice as far away, what happens? When dilating from a point on the line, the equation of the line does not change. So please fill in the highlighted words in your notes. Pause the video if you need more time. Example 1. The line y equals 2x minus 1 is dilated by a scale factor of 2, centered at the point 1, 1. Write the equation of the dilated line. So, step 1. Test to see if the point is on the line. How do we do that? We substitute. X value is 1, y value is 1, so we substitute. And when we solve, we get 1 equals 1. So the point is on the line. Step 2, if the point is on the line, the equation does not change. So we have y equals 2x minus 1. Pause this video if you need more time. And let's move on. What if the point is not on the line? So let's say the center is 5, 0 instead of 0, 0. And we want to dilate it by a scale factor of 2. So here we see that the black dot is 5 units away, so doubling that will be 10 units away, scale factor of 2. And we go both in the y direction and the x direction. And what happens when we connect those dilated points by a scale factor of 2? We see that the lines are parallel. Let's look at another example. We have 2 lines that are parallel. When dilated from the origin 0, 0 by a scale factor of 2, every point is 2 times as far away from the origin as the original. So you see that the purple line is 2 units away and the red line is 2 units away. Okay? Now, fill in the highlighted in the key concepts. When dilating from a point off the lines are parallel. The slopes stay the same, and the y-intercept is multiplied by the scale factor. So we already know that parallel lines, they have the same slope. So if the point is off the line, you just multiply the y-intercept by the scale factor. Pause this video if you need more time. Moving on. Example 2. The line y equals 2x plus 3 is dilated by a scale factor of 4, centered at the origin. Write the equation of the dilated lines. So again, test to see if the point is on the line. You do that by substituting. And the origin is 0, 0, so I substitute those for x and y. And we see that 0 does not equal 3. If the point is not on the line, we multiply the y-intercept by the scale factor. So the y-intercept is 3, so 3 times 4 is 12, and you leave the slope the same. Summary. If your equation is not in standard form, get y alone. And then step 1, substitute the points to see if they're in the line. If the values are equal on the same side, the point of the equal sign, the point is on the line, so the line is exactly the same. If the point is off the line is parallel, and all you do is multiply the y-intercept by the scale factor. Keep the slope the same. So try out the checkpoint using these steps, and try to get to level 2 to move on to the next lesson. See you next time.